my explanation of what it is that makes our super PAC Valor America special, what makes us unique, what makes us effective. That difference is called randomized controlled experiments. This is an expression that is barely known in Republican election circles, and it's a problem. On the left, in the Democratic Party, knowledge of this method of testing is widespread and it's almost universal. Every major campaign uses them, and the difference that it makes is significant. If you want to simplify it into vote increases, it's as simple as this. The usage of randomized controlled experiments can make any campaign grow its vote by about 2%, sometimes more, could be 5 or 6%. To be precise, generally we're talking about a reduction of the opponent's vote by that much and an increase of our candidate's vote by the same. Obviously, in a close election, this means everything. In an election that would have been 50-50, this means our guy wins. 51-49, this means our guy wins. It's a very important thing. So what is it? And why does it matter? And why doesn't anyone know about it? Well, it's very simple. Basically what this is something that was developed on the left, and we all kind of know that it's going on. If you spend much time reading about the Democratic election world or the Democratic advantage during the Obama years, you always hear mention of big data, micro-targeting. You hear all sorts of mentions of the data revolution. There was a book called The Victory Lab written that talked a lot about this. There have been quite a few studies of it on the left. And people on the right have read those studies. Generally, they just don't understand what's being talked about because they don't know what these things are. It does require a little bit of detailed knowledge to really understand them. But let's stick with the 30,000 foot view. Randomized controlled experiments. Well, the idea here is we're trying to determine what works and what doesn't work. What advertising actually motivates the voter to vote, motivates the voter to vote for our guy. What messaging turns him off? What messaging makes him stay home? Up until the year 2000, pretty much the only way this was done, left or right, was guessing. And it's sort of the nature of the election world was guessing. Experienced people, campaign managers, political consultants, would come in and they'd guess. That was their job. Their job was to say, I've done this before, I know what works, I know what doesn't work, and in this situation, here's what works. Well, as the internet grew and more information about people became much, much more accessible, there became a lot of opportunities to analyze what makes people do this and what makes people do that. The business world figured this out early on, and the world of consumer product testing very much took advantage of data, of information, especially that information gathered through the internet. We all know that. We all have some awareness that because we go on Google, because Google's gathering information, they know our buying habits. But how do you take that data and use it to win? How do you determine, based on information, what works and what doesn't work, what persuades and what doesn't persuade? Well, the answer is you have to find a way to test in advance what works and what doesn't work. And both the right and the left try to do this. There's lots of efforts to test. Testing isn't new. It's testing that works that's new. Now, what testing doesn't work? Well, we all know about focus groups. We've all turned on Fox News and we've watched a group of supposedly undecided voters watch a debate or watch an ad, and then they're asked, what do you think? And they tell us what they think. The problem is that almost invariably those people are telling us what they already thought. And the ad might well confirm what they already thought, or they might dislike it because it goes against what they already thought. But them telling us things doesn't really give us much real knowledge of what would happen if they saw ads out in the real world. When we're asking them to tell us what you think of this, we get a whole variety of answers. I think we all sort of know this, don't we? Don't we all understand that if I show someone something and say, what do you think? They immediately say to themselves, what am I supposed to say? What's the right answer? What does this person want me to say? And a lot of what they say is conditioned by all sorts of prejudices and calculation. This is a very bad way to test, although it's very common. It doesn't really help us very much. There's other testing. A/B testing is one thing that I think all of us have heard. We have ad A that talks about peanut butter is terrible, and we have ad B, which says peanut butter is wonderful. We show them both to similar people, and we see which one people seem to like more. Again, there's that problem of asking people what they like, but generally A/B testing sort of works. This versus this, we get something useful from that. But at the end of the day, when you're trying to figure out what will make you change your mind, this is the hardest thing to test. And this is the thing that nobody tests very well. The left figured it out first, and the right has finally started to do the things the left did back in the early 2000s. And there's a kind of testing called field experiments that are used pretty widely on the right, and they do tell us some useful things. They are good. But randomized controlled experiments are the next thing. And for whatever reason, the right isn't there yet. The left is. Now, what is a randomized controlled experiment? Well, basically what it is we try and take a whole bunch of possibilities, a whole bunch of potentially persuasive messages. And our goal is to do what you do in a drug test. Imagine these messages as 8 different drugs. And we want to figure out, are any of these drugs effective? And we're worried about the placebo effect, right? That's always the big problem in a drug test. Someone might get healthy, but do they get healthy because the medicine works, or do they get healthy because they know they're taking the drug? So our goal is to try and test things that get around that psychological effect. So in our laboratory, the way we do that is we show people things, randomly they see stuff, and oftentimes they don't even know what it is we're trying to figure out because they see other messages mixed in that are there to kind of cloud what the purpose of the test is. But we find a way, there's a way within the tests that we do, to measure reactions without people seeing us measuring them. And this is where the data world comes in so wonderfully. We don't have to ask the person very many questions because we know the answers already. Thanks to this data world, we know probably 1,000 things about every person who comes into our experiments. So a typical randomized controlled experiment would have 1,000 people in it. They come in to possibly a room. More often they're logging in from their home on the internet, and they're answering some questions and watching some videos over their computer. There's questions in there, mostly what you'd call palate cleanser questions we ask them, but we really don't care what they say to, where their answers are unimportant. They're there kind of just to get their mind off of election stuff. They might see a series of ads, some of which are political ads, some of which are not. They don't know that they're seeing one thing and someone else is seeing something else. But usually that's what's happening. We break up 1,000 people, let's say, into 8 groups, and each group is seeing one of the ads, and we try and measure after them seeing their one ad what their feeling is about the election in question. It gets very complicated about the exact way this is set up, but I think you can understand the idea. So we're showing people messages, and then we're measuring how they respond to it, trying to avoid them knowing that we're measuring that, looking for responses without asking them directly, do you like this ad? Okay, so what does this allow? It allows us 2 very important things. The first one's the easy one, obvious. It tells which ad works, right? It's as simple as can be. Let's say there's 8 ads. Let's say 5 of them just don't work. In fact, worse than don't work, they make people angry. They make people want to vote for the other guy. No, those ads we don't touch, right? Let's say there's 3 that are good. There's a difference. One is very good, one is pretty good, one is almost as good as the first, right? They're different, but all three net positives. Okay, this is important information, and we can determine what it is, who, who liked the ads, right? In our 1,000 people, we end up with some who did and some who didn't. Well, this is where it gets fun. This is the second thing, and this is the thing that no one on the right does. It's called modeling. It's the simplest word. This is the thing people call micro-targeting sometimes. And the right does this terribly, and the left does this wonderfully. The reason the left does it wonderfully is they designed all this. They came up with all of these ideas. They hold on to them. They're glad we don't know. They don't want to help us know. And they dominate the institutions where these things are done. So modeling is real simple. You take the people who liked the ad and you look at them. You look at all that wonderful data that we can get through Google and the internet world. And you say, what do these people have in common? Let's say we have 312 people, and they all liked one of these three ads, right? And we then look at those 312 people based on this data, looking for commonalities. Maybe it's religion, maybe it's voting, maybe it's where they live, the kind of home they live in, the amount of money they make. It can be all sorts of things. But what we're looking for is where there's overlap, right? Now, this is where it gets very complicated. This is where the scientists are essential, because there's so much data, 1,000 data points on each person. We got to figure out, well, which data matters and which data doesn't. What if it happens that all 312 people have a organic garden? Does that matter? Does that have anything to do with the ads we showed? Is ownership of organic gardens an important quality for the people who we can persuade? And the answer could be yes, and it could be no. And our scientists are looking for what data is superfluous, doesn't matter, just coincidental, and what data really does matter. And from that, we develop a model. I assume this starts to make some sense. What does the persuadable voter look like? What does the most persuadable voter look like? What is the somewhat less persuadable? What is the somewhat less still persuadable? And we start ranking people. We take that model, though, those several hundred people, and then we extrapolate to the entire voter world that we're working in. State of Minnesota, let's say. And so we take 300 people, and we can take that information and extrapolate it to several million voters. It's very powerful, but you have to do it right. This is the devil's in the details. If you get the modeling wrong, then your model, the group you end up with of supposedly persuadable Minnesotans is worthless. You got to be able to do this right. And this is something the left, they have it down to an amazing science. They've done this hundreds of times since 2006. This was all developed after the 2004 election, and they've been doing it again and again and again. And some of their ability at this is just extraordinary. They still lose elections, but they can lose them by less, and in some cases win them. And we aren't doing this at all. And if we did this, the advantage they have will be neutralized. The several percent, 2%, 3% of extra votes they get will be shifted back our way, and we'd get them. And in close races, we'd win. Randomized controlled experiments is boring as hell. If you sat through 15 minutes of this talking, you could say, wow, Joe Arlinghouse is boring, and I don't know that I even understand what he said. But the difference it makes is the difference between winning and losing. If you heard nothing else I said, hear this. Since the year 2000, there have been 33 candidates, Republican candidates, for the United States Senate who have lost their election by less than 6% margin. 33 Republican candidates lost by less than 6%. 15 of them lost by less than 3%. 10 of them lost by less than 1%. Randomized controlled experiments in each of those elections would have made everyone of those 10 that were closer than 1%, a Republican victory. Would probably have made all of the 15 a Republican victory, the less than 3%. And even some that are up to the 6% would have won just by using this one technique. That's how powerful this is. It's shameful that we don't get it. It's hard to fix because it requires a kind of data scientist that doesn't work in the Republican Party at this time. There's 5. But we can learn this, we will. The existence of my super PAC is exclusively to use this. We happen to be the one that gets it, and we're going to use this powerfully in 2018, as we did in a small way in 2016, and an even smaller way in 2014. We're going to use it, and we're going to win. So hopefully my rambling here has helped you understand randomized controlled experiments. Thanks a lot. Hope you'll continue to listen to some of my videos. Take care. Bye-bye.